Even today, astronomers cannot say with certainty whether the universe is finite or infinite. Most of the observations support this second theory. It is not excluded that it is finite. However, even in that case it would have no limit. It would be so curved that it would look like a ball. The universe would then be infinite but would have finite volume. How big is the universe? According to today's knowledge, the universe was formed approximately 14 billion years ago. This means that we cannot detect radiation older than 14 billion years. In other words, no light coming from the depths of space could travel more than 14 billion light-years. This does not mean that the universe at that distance is shrinking. It can be much larger than the range of our telescopes. It can even be infinite. Does the universe have a center? When it was determined that almost all galaxies are moving away from us, the conclusion was that the Milky Way lies at the center of the universe. However, as logical as it is, this thought is wrong. Namely, in reality, galaxies are barely moving, but that is why the space between them is expanding. Similar to a balloon that we inflate, all points on the surface move away from each other, but none is the center of the surface of the balloon. The same would apply if the universe were not curved, but infinitely large. Such a universe would not have a center either, although it is very difficult for us to imagine. Are galaxies rushing towards us? Although the universe is expanding, there are galaxies moving towards the Milky Way, for example. Andromeda, which is approaching us at a speed of about 300 kilometers per second. To understand this seemingly paradoxical fact, we must distinguish two phenomena. On the one hand, the movement of the galaxies themselves in space, and on the other hand, the expansion of the universe itself. The universe is expanding at a speed of 21.8 kilometers per second in a diameter of 1 million light-years. However, the movement of the galaxies themselves is usually hundreds of kilometers per second. Therefore, in close galaxies, the expansion of the universe is not crucial, the movement of the galaxies themselves predominates. In very distant galaxies, the opposite is true. The movement of the galaxies themselves in this case is negligible in relation to the expansion of the universe. That is why distant galaxies, due to the expansion of the universe, seem to be moving away from us, while close galaxies are moving both towards us and from us. Will the universe expand forever? There are three possible scenarios for the future of the universe. First of all, the expansion of the universe due to the action of gravity can be slowed down and stopped, and it can turn into a contraction. The universe would eventually disappear into the so-called Great Collapse. Second, the expansion of the universe could slow down, but it would take time, in which case, the expansion would stop after an infinite amount of time. And third, the expansion of the universe would accelerate over time. Until a few decades ago, astronomers were convinced that one of the first two scenarios would happen. But then they came to an unexpected discovery. Star explosions in very distant galaxies proved that the spread is intensifying. Why this is so, scientists still do not know. Apparently some mysterious dark energy fills the cosmos and encourages its expansion. The most distant object that can be seen with the naked eye is the Andromeda galaxy, about 2.9 million light-years away. It is a spiral galaxy, similar to the Milky Way, the galaxy in which we live. With the help of the largest telescopes, astronomers today can see galaxies as far away as 13 billion light-years away. However, researchers encounter an insurmountable obstacle here, because every view of the universe is at the same time a view of the past of the universe. So, when we look at a galaxy 13 billion light-years away, what we see is its appearance from 13 billion years ago, when the first galaxies formed. Before that time, there were no objects that we could see, which also means that we cannot look deeper into space. Although it is often used in the context of measuring time, a light-year is not a unit of time, but of very long distances. A light-year is the distance that light travels in a year. Since light travels at a speed of about 300,000 kilometers per second, a light-year is about 10 billion kilometers, so it is an ideal measure for determining the distance between stars and galaxies. Various methods are used to measure distances in space. Astronauts from Apollo set up a laser reflector on the Moon, with which the distance to the Earth can be measured in centimeters. The distance from other celestial bodies in the solar system can, for example, be measured by radar, i.e. by repelling radio waves. Of course, this method cannot be applied to stars. Then astronomers generally apply the following technique. They determine the position of the star at intervals of half a year, i.e. on opposite sides of the Earth's orbit around the Sun. As the angle of view from the Earth changes, so does the position of the star in the sky, all the more so if the star is closer to us. The distance to the star can be calculated based on the displacement based on the known diameter of the Earth's orbit. This parallax method is applicable at distances up to approximately 1,000 light-years. To measure distances to even more distant objects, e.g. galaxy, astronomers must apply indirect methods. The so-called Cepheid. These stars change the intensity of the brightness in a characteristic way at regular intervals. Since it is known that these time intervals depend on the actual brightness of the star, their measurement can determine the actual brightness of the star, and thus its distance.